Hey guys, my name is Raquel and today I am here to talk about thermoanalytical techniques. Thermoanalytical techniques start to be studied and invented at the beginning of 20th century, and thanks to scientific and technological advances it was possible to design and develop thermoanalytical equipment with a high degree of sophistication that allows development of new products and improve the quality control. Thermoanalysis is the study of relationship between a sample property and its temperature, while the sample is heated or cooled in a controlled manner, and we can obtain information about mass variations, thermal stability, melting and boiling points, glass transitions, between many other factors. Today, I am going to talk a little about thermogravimetry, differential thermoanalysis, and differential scanning calorimetry. Thermogravimetry, or TG, is a technique in which the sample mass is recorded as function of temperature, and we normally do three types of analysis. Isothermal, where the temperature is constant and the mass of the sample is measured as function of time. In the quasi-isothermal, the sample is heated to a linear ratio as long as the mass is constant. When the balance detects variation in mass, the heating is kept constant. And finally, we can do a dynamic analysis, which follows the variations in mass suffered by the sample as a function of temperature when it's subjected to linear heating or cooling. This is an example of TG curve. In derived thermogravimetry or DTD, we obtain the curves that correspond to the first derivative of TG curve. That is, the first derivative of the mass variation is registered as a function of time or temperature, and the peaks obtained, the limit area proportional to the change in mass undergone by the sample, and the temperatures will be more exact than in the TD curve. Differential thermoanalysis, or DTA, is a technique in which the temperature difference between a sample and a reference material is measured as a function of the oven temperature or time, with the heating or cooling ratio having to be linear. This curve shows the events that the sample undergoes when subjected to heating, that it can be exothermic when releasing heat, and normally these events are shown upward in the figure, or due to heat absorption, endothermic and in the opposition direction. TD and DTA techniques can be measured in the same equipment or separately, and the curves are usually analyzed together to obtain more conclusive information about a sample. Here we see the TG curve in black, the DGG curve in red, and the DTA curve in blue, referring to the analysis of 30 to 650 degrees of glycerol, with a heating rate of 10 degrees per minute. The TG and DTG curves of the glycerol show two mass losses, and in the DTG the peaks become clearer. Initially, evaporation of volatile compounds such as water present in the sample occurs in the range of 30 to 170 degrees. Glycerol was stable up to 170 degrees, the temperature at which it started to evaporate and degrade. This is the first loss of mass, and this process continues up to 208 degrees and is related to the endothermic peak at 208 degrees in the DTA curve. The second stage of mass loss refers to the oxidation and degradation of residual glycerol and occurs in the temperature range of 208 degrees to 550 50 degree and can be associated with the exothermic peak at 350 degree in the DTA curve. Differential scanning calorimetry with heat flow, or DSC, is a technique with the difference in the heat flow ratio between a sample and the reference material as a function of temperature is determined. As in DTA, the area of the DSC curve is directly proportional to the change in enthalpy. The main difference between DSC and DTA techniques is that DSC performs a quantitative analysis, being able to determine the enthalpy involved in endothermic and exothermic events. Glycerol had two endothermic events. The first, at 110 degrees, is related to evaporation of water present in the sample, and the second represents the evaporation of the same at 208 degrees. So, we see that the DSC curve confirms the event of the DTA curve. There are several factors that can affect all of these techniques, such as furnace heating rate, equipment calibration, natural size and crystallinity of sample, amount of mass, among other factors. Therefore, we must always be attentive to these details in order to obtain exact results on the sample that we are going to analyze. I broke here in general of main thermoanalytical techniques. There are many other details that encompass the world of thermoanalysis, but that is a subject for another day. I hope you enjoyed it and see you next time.